7b78 magic angle spinning P3 formula UFO. It's line 22 we're still working on, and there's the alien radio signal. June 16, 2013. This is about the magic angle spinning vortex laser beam diffraction photon energies for UFO power engine formulas. For to do, it's cross-reference miniboone experiment Janet Conrad's data from lines 1 to 27 when finished doing data research. This is a 4-part video series, so you want to take a look at the other ones. So we have 7b76, which is part 1a, 7b76 part 1b, and it's all called magic angle spinning part blah 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 formula. So there's part 1a, 1b, and then there's part 2 and part 3. Okay? And it's 7b76 to 78 is what it goes from. So solid state nuclear magnetic resonance to magic angle spinning. The keywords from the formula found the data from the previous video is 76 magic angle spinning P1 formula UFO. PF2, sorry, it's P1A. Yeah, I just correct it as I go along. I forget to do stuff, so this is the best way to do it. There we go. So P2 and then P3, okay? Originally it came from 7b73, which was isotropic interaction formulas, and then another one from 7b75, velocity PSO NRF swarms. So any condensed phase, and here we don't have the quote again. I don't know if this is wiki or a blog. No, it's got to be wiki because I didn't put the blog link. So it's quote wiki. In any condensed phase, a nuclear spin experiences a great number of interactions. The main three interactions are dipolar, chemical shift, anisotropy, quadrupolar, often lead to very broad and featureless lines. However, these three interactions in solids are time dependent and can be averaged by a mass. The nuclear dipole-dipole interaction between magnetic moments of nuclei averages to 0 only at the magic angle of 0m. The chemical shift anisotropy, a nuclear electron interaction averages to a non-zero value. The quadrupolar interaction is only partially averaged by mass, leaving a residual secondary quadrupolar interaction. In liquids, example, a solution of an organic compound, most of these interactions will average out because of the rapid time average molecular motion that occurs. This orientation averaging solution is mimicked by mass of a solid. This causes the signal to become much narrower, giving rise to the isotopic value, which is of the interest for structural determination of solid materials and compounds. And spinning sidebands, which occur at multiples of the spinning speed and can be used to determine the chemical shift anisotropy of the nuclei. The physical spinning of the sample is achieved via an air turbine mechanism. These turbines or rotors come in a variety of diameters, outside diameter from 1.3 to 15.0 nm. Or mm, and are usually spun on air or nitrogen gas. The rotors are made from a number of different materials such as ceramics, examples zirconia, silicon nitride, or polymers such as polymethylene macrolide, PMMA, or polyoxymethylene POM. The cylindrical rotors are axially symmetric about the axis of rotation. Samples are packed into the rotors, and these are then sealed with a single or double end cap. These caps are made from a number of different materials, example KLF, Vespel, zirconia, or boron nitride, depending on the application required. Just so you know, each of these keywords that are in this particular data actually create another 20 videos of formulas to go with them as well. So magic angle spinning was first described in 1958 by Edward Raymond Andrew, A. Bradbury, and R.G. Eads, and independently in 1959 by I.J. Lowe. The name magic angle spinning was coined in 1960 by Cornelius J. Gorder at the Ampere Congress in Pisa. Formula from data part 3. Condensed phase nuclear spin interactions, 3 dipolar chemical shift anisotropy, quadrupolar monopole magnets, quadrupole magnets, broad featureless lines, visible light, 3 interactions, particles, solids, time dependent mass. MAS, not mass. But nuclear dipole to dipole interaction between magnetic moments. Nuclei averages 0, magic angle is 0m, chemical shift anisotropy, nuclear electron interaction non-zero value. Quadrupolar interaction MAS, residual secondary quadrupolar interaction. Liquids, argon gas, mixture, neutrinos, solution, organic compound, interactions, average, rapid, time average, molecular, motion, colliding, MAS, solid. Graphite wafer, crystal wafer, electron hole, Higgs boson signal, CERN 2012 results. Signal, Higgs signal, protons, narrow ribbon pencil, electron. I got signal there twice. Take that signal out there. Yeah. Higgs signal, protons, narrow ribbon pencil, electron, laser beams, rise isotropic value. Structural determination solid. Materials, compounds, ligands, spinning sidebands occur multiples, spinning speed, split fermions, split leptons, plus 3/4 spin. To determine the chemical shift anisotropy, nuclei, spinning, physical spinning particles, air turbine mechanism, create vacuum, carbon to carbon nanotubes, turbines, rotors, airlift, diameters, outside diameter core, bendable metal thickness is 1.3 to 15 mm, spun, air jet streams, nitrogen gas. Rotors, airlift, magnetic forces, 5 axial forces, new standard model particles from WOW data, lines 17 to 22. Different metals, I've changed that to different super alloy metals that came up in the WOW data. That's in the WOW data formulas. And it's in line 22, I believe. We're going to add some materials. Ceramics, cross-reference line to 1 to 27 in the WOW data. Zirconia, silicon nitride, polymers, polymethylacrylate, PMMA plus POM, polymethylene, cylindrical rotors, axial symmetric axis rotation, core, crystals, mesh, lattice, electron holes, nanowires, microwires. Particles packed into rotors, airlift, sealed, ceramics, single, double cap, end cap. Caps, different bendable metals, materials, kelp, F, Vespel, zirconia, boron nitride. Google them in the next several videos. The keyword to Google is microscopic inhomogeneities from the same formula data in the next video. Thanks for watching.